Testing 1, 2, 3. Use the graph below to describe the end behavior of the graph. Let's take a look at our graph first. Our graph is pointing down in both directions, which tells us that it's an even graph as well as a negative graph. So describe the end behavior. Remember that end behavior is as x approaches negative infinity, y approaches something, and as x approaches positive infinity, y approaches something. So let's take a look at that. As x approaches positive infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity. So the next question asks us, let's formalize the language to describe the end behavior using limit notation. Now, limit notation is something that we have not seen before. However, finding the limit of a graph is exactly end behavior. So we write this as the limit as x approaches negative infinity, f of x approaches negative infinity. And the limit as x approaches positive infinity, f of x approaches negative infinity. So again, finding the limit and end behavior are the same thing. Let's talk about f of x real quick. You've seen this before, but maybe you don't remember what it is. F of x is literally another name for y. If you plug in a value for x, you get an output value, right? X is input, y is output. So let me show you an example. So if you had y is equal to 2x plus 3, this is the same as saying f of x is equal to 2x plus 3. So if we plug in a value for x, let's say 3, you get 2 times 3 plus 3, which is 6 plus 3 is equal to 9. So f of 3 is equal to 9. If you were to plug in 3 right here, you would get y is equal to 9. And these two are exactly the same thing. So now let's talk about what a limit is. So the limit of f of x as x approaches some number a, we get a limit, L. So we write this as the limit as x approaches a, f of x approaches L. Now let's take a look at number 3. Let's evaluate some more limits. So if you notice, there's something right here that looks like an exponent on the 6, but it's a negative and a positive sign. What does that mean? So if you think about a graph, this side of our graph is when x is positive, and this side of our graph is when x is negative, which means that A is asking the limit as x approaches 6 from the left side, f of x is approaching what? And B is asking as x approaches 6 from the right side, f of x approaches what? So when you see a negative exponent, that means you are looking at your graph from the left. And when you see a positive sign, you are looking at your graph from the right. Because again, x is positive on our right side and x is negative on our left side. So now let's take a look at our graph. So we are trying to find our graph as x approaches 6 from the left side, f of x approaches what? So from the left side, f of x approaches 6 at that value there, and that value there is 6 comma 0, which means f of x approaches 0 when x approaches 6 from the left side. Now, as x approaches 6 from the right side, f of x approaches 0 again. So when the left-hand limit and the right-hand limit are the same, the limit as x approaches 6 and f of x then approaches 0, that number that the right hand and the left hand approached. Now D, looking at D, f of 6 simply means when x equals 6, what is y? What do we get on our graph? And we already said that 6 comma 0 is our point there. So f of 6 is also 0. Now let's take a look at our next one. The limit as x approaches 3 from the left side, f of x equals what? So let's take a look at that. So as our graph approaches 3 from our left side, we get, let's see, this looks about, let's call that negative 35. So that means that the limit as x approaches 3 from the left side, f of x approaches negative 35. And as x approaches 3 from the right side, again, x approaches negative 35. And remember what I said, when the left-hand limit and the right-hand limit are both the same, then as x approaches 3, f of x approaches that number as well, which is negative 35. And f of 3, this point right here, is 3 comma negative 35. And again, this is an estimate. You could have said 36, 37, somewhere between, that's under 40, under negative 40, but less than 30, somewhere in between here. So f of 3 is equal to negative 35. Now let's take a look at the back. So now we have a fancy looking graph here, which looks really complicated, but actually it's not so bad. So our first question asks us, as the limit as x approaches infinity, f of x approaches what? So as x approaches infinity, f of x approaches, and it looks like it's going to go like this and not come down, and this looks like 1, 2, 3. It looks like perhaps there's an asymptote here, which means that as x approaches infinity, f of x approaches 3. And as the limit of x approaching negative infinity, f of x is approaching, keeps going toward negative infinity. Let's take a look at our next one. The limit as x approaches negative 4 from the right side, f of x approaches what? So where's our negative 4? We have 1, 2, 3, 4. So as our graph approaches negative 4 from the right side, f of x is equal to 4, 5, 6, looks like 6. And as the limit as x approaches negative 4 from the left side, f of x approaches 6 yet again. which means that the limit as x approaches -4, f of x approaches 6. And f of -4, so this point right here is -4, 6. So f of -4, if we plug in -4 into our function, we would get 6. Our next one says the limit as x approaches -1 from the right side, f of x approaches, so let's see, so here's -1, so as f of x approaches, let's use a different color. So as f of x approaches -1 from the left side, right, f of x approaches as f of x, here's, let me erase that.